So the question is given as that we have to sort the array, and the twist is we have to do this in place. Like it means we don't use to any extra space there. We have to do sorting on its array. So our input is changing there. So it means the very brute, that means use simply sorting or use extra vector doesn't allow us, because because problem states that you can't use, you have to do in place. So like let's say first of all take the test case there, and now uh, so this is our input, and this should give us as a 0, a 0 and 1, 1 and 2 and 2. So this should be output of for this input. So how we do this? So first of all, like we have to do in place operation, so we can't use any kind of data structure there. So in let's say like uh, what's the intuition that comes, that uh, we can assign we have to do operation on separating these zeros, ones and twos, such that they'll become the sorted array. Mean what I'm trying to say, for sorting of the array, what I want, like 0 must go on the left outside. Let's say first of all I'm talking about the what are its relative positions. So 0 is going to left side of the array, 2 is going to right side of the array, and 1 is in some middle. So these should be the final positions of this 0 1 2. So basically, like let's say whenever we have to handle like here we have to handle three things. So let's say I assign three variables, let's say I, j, k, or any kind of, but to make a more readability, let's say I may be I may be given any of the name which I can handle, let's say for 0, and second pointer which handle for 1, and third pointer which handle for 2. Like they simply decide what should be the exact location, or they should be deciding what should be the position of 0 1 2 in the array. So okay, let's say I'm given the let's say I'm assigning the pointer L. It did not let's say first of all this is for 0, and this is like first of all I write code, then I explain it. This R is, this is MS. Okay, so what they are suggesting there, so L basically it means the po position of where should 0 to go, where should 0 to go. So basically it shows up by L. Similarly R is showing that where should 2's to go. Okay, and the final is basically this mid is, it is nothing but the current position of. So we don't have to bother about the 1, because when we set of zeros and when we set to twos, so 1 is already become in the middle, so we don't have to bother. So basically L is denoting where should the zeros go in the direction, zeros goes in the array, and similarly this R shows where should be our 2 go. So basically this L and R deciding where should 0 and 2 going. So by making their relative position, they are already become sortable, that according to our output. Like okay, so basically what's my approach there, I just initialize our L is equal to 0, means I initialize our 0 as, because I'm wanting to the at the starting of the end array, and similarly I want 2's to the end of the array. So I initialize R is n minus 1, and let's say this mid vector is going from traverse from 0 to till end, such that it is less than it is just previous to R. it doesn't exceed it. Okay, so there is a while, and it is when mid is going to end of the array, but it doesn't exceed r. Okay, so after during traversing, it processes many of the elements, and it's check whether it is 0, whether it is 1, whether it is 2, and accordingly it perform the operation. Like mean, let's say if mid of it is 0, let's say there's one case like we can delete. There is if v of mid is equal to 1. Okay, or the third remaining case is if v of mid of 1 equal v of mid is equal to 2. So if our current position, if the current element is 0, so what it means, if current element is 0, so we simply put it 0 at the starting of the array. And how I denote the starting of the array, I use the simply L vector, L pointer there. So what I'm trying to say, I simply swap our v of mid comma v of L there. Okay, so this is and now after swapping it, so the L pointer, the L value is coming to mid position, and mid value is going to L position, and now we simply L plus plus and mid plus plus means to till mid we do all of the operations. Okay, so now coming to the second condition, when our current element is 1, so what we do, so doesn't worry, like if it mid, so just remain this. Okay, so continue mid plus plus. Okay, now the second case, like here similarly, if our current element is 2, so our target is to move this 2 to the right end of the array. So what we do, we swap this value to the rightest most elements, which is denoted by r, and now we r minus minus and the mid plus plus. Now there's a fault there, like there's a very critical thing, it's a very interesting thing there. See, let's say I explain you by example. Let's say this is 2, this is 0, this is 2, this is 1, this is 1, and this is 0. Okay, so in the first bracket, when I'm during traversing, when I found my current element is 0, let's say this is my current element and this is 0, so I can simply swap it this with and I move both pointer, our L pointer and our mid pointer. Why? Because the coming element that comes to this mid is already checked, so we simply skip that. So that's why I make forward mid. But there's one thing there, if I have to judge during traversing, if I found my current element is 2, so if I swap this element with this ending element, let's say let's say I'm defining its position also, let's say L is somewhere there, I like it doesn't require, and there's a mid, yeah, okay, so let's okay, so see this, so there's our L pointer, there's our mid pointer, and similarly there's our R pointer. Okay, so now what I'm trying to say, if I deal during traversing, if I find my element is 2, so I swap this element with this element. What it means, this 2 goes to end point. Okay, so this is nice, but the thing is, here maybe what are the possible cases, what are the previous element that was there, like it may be 0, it may be 1, it may be 2, so that point comes to this point too, so it may be 0, it may be 1, it may be 2. Okay, so if so it means we can't proceed this. So if we simply this mid plus plus line means we don't proceed this, so it like we skip this operation. So means we don't judging its we don't locate its exact position, so that's why our answer may be answer is wrong. So that's why I have to skip this line. I think like okay, I'm again explaining it. Wait a second. Okay, so I'm explaining it again. Let's say this let's say this is there is a 2 initially, there is a 2, there's a zeros and there's a 1, and maybe there can be there is a 0 then 1 or 2. Okay, so when I traversing from initially, and if at a situation, if my mid current element, if I'm mid means basically current element, so if current element 2, it means I have to place this 2 to the end of the array, means I have to swap this with our r most element, and if I can swap this, so I can move backward r. Okay, so it means then this 2 goes to there, so it be and obviously there is a swapping, so these positions comes to there and there become 2. Okay, and after doing this operation, since 2 is 2 is placed at its correct position, so that means we can move backward to our r. Okay, so our r becomes to at this stage. Okay, but there's a scene condition like we do on the operation at the time of the moving of the 0. Similarly, operation we can't do at the time of operation 2. Why? Because the things, the element that come here are not processed yet. If I move or my pointer mid, means I didn't proceed this, that turns to the wrong output. Okay, and why it doesn't bother in the case of the 0. So when I found my current element is 0, so I swap this with my starting element, and I simply move we we see it there. So if I adjust our 0 position, so we can simply l pointer il plus plus, and since we start our mid from left to right, so all it means that we have to we set all of the rest left or leftist elements like हमारा मिड जो है वो शुरू से लेके एंड तक जाता जा रहा है, तो जब वो जिस भी पोजीशन से आ रहा है, तो इसका मीन है कि वो अभी तक के सब सारे एलिमेंट्स को एडजस्ट करता जा रहा है। तो जब वो राइट मोस्ट एलिमेंट, जब जिसका लेट से का दो केस बनते हैं, जब मिड की वैल्यू जीरो आएगी, तो जीरो आएगी तो वो जीरो स्वैप करेगा अपने स्टार्टिंग वाले एलिमेंट को और वो एल प्लस प्लस बढ़ा देगा। ठीक है, और क्योंकि अब उसने ये वाला जो अब यहाँ पे टर्म्स आई है उसको भी उसने कर लिया है, तो अब सिंपल मिड प्लस प्लस कर सकता है। बट जब ये मिड अपने एंडिंग वाले एलिमेंट, मीन जब करंट एलिमेंट 2 होगा और जब ये एंडिंग वाले एलिमेंट से स्वैप होगा, उस टाइम पे हम सिंपली आर माइनस माइनस तो कर लेंगे। ओके, बट अब हम मिड प्लस प्लस कर लेंगे तो क्या होगा, जो टर्म्स यहाँ पे आए वो अभी प्रोसेस हुए नहीं है। प्रोसेस नहीं हुए मीन्स वो अपनी करेक्ट पोजिशन पे नहीं आए, सो इट मीन्स हम मिड को मूव अभी नहीं कर सकते। तो देयर इज अ क्रिटिकल कंडीशन like we see in the fast of the operations, we can like simply replicate this condition into this condition, but this might be false. So why this is different from this? Because we starting our mid from the left to right, and we know very well during traversing, whole of the traversing, we can doing its work on step by step. So to which step mid comes to there, it it ensures that all of the elements before it are processed. Okay, so I think this, so let's check whether it is so there is a 6, there is a 2, there is a 0, there is a 2, so 1 1 and 0. So what should be the, okay, so why is it there? So while mid less than equal to r, if v of mid equal to 0, so we can swap our v of mid with v of l. Okay, so l plus plus and mid plus plus. Okay, don't worry. Else if v of mid is equal to 1, so mid plus plus, else swap of v of mid comma v of r. Okay. Mid equal to 0 and swap v of mid comma v like to place similarly it is to place 0. Because the coming element okay. So the thing is okay, the code is correct. We forget to print it. So it is c out of v of I. There is, and after it is and l. And now let's check. We forgot to print the output and we expected. So yeah, so there's a 0 0 1 1 2 2, means that is over. And what is the time complexity here? So we see simply of n there, n spaces of 1. Okay, so thank you.